I am going to finish up section 5.5 in pre-algebra. I wanted just to go over some of the word problem parts. So this section was on proportion. And so the important thing to remember when we're looking at equal proportions, equivalent proportions, if you have, like, you need to check whether they're equal, then you have A over B equals C over D. And so you always multiply the A times D equal to the B times the C. And it's important that when you set up these proportions that they're equal. So getting into the word problem part, if you are looking, again, proportions are just a comparison, equal ratios, I guess was what I'm trying to say. These are your ratios. So you want to make sure if you are comparing students to adults, that the second proportion is set up students to adults as well. You've got to make sure that whatever that number is representing in a word problem, that it's the same part of the fraction on either side. So if you look on, let me see, I'm having to go back and forth, so I apologize. It's going to be a little bit slow sometimes. Page 205 is where we sort of start with example 4. So we have the ratio of adults to students on a bus is 2 to 7. If there are 8 adults, how many students are on the bus? Now again, the examples that we started out with are pretty simple. I think most of this class can probably do it in their heads. But if we have a ratio, let's see, theirs is probably the opposite of what I just did as an example, right? It was, sorry, let me pull it back up. Adults. Adults is 2, students is 7, and there are 8 adults. All right, so in our example, we have adults, students. So the ratio is 2 to 7. Internet's acting up even at home, 2 to 7. And we know that we have 8 adults, and we want to know how many students do we have. So we use the form 2x equals, well, I'll do 7. 7 times 8. So this means that 2x equals 56. And to undo multiplication, we use division. So we're going to divide both sides by 2. And 2 goes into 5 2 times with 1 left over, and 2 goes into 16 8 times. So there's 28 students. Now, you guys have done this previously like this. So if you have 2 over 7 equals 8 over x, then you just say, okay, what did I do to get from 2 to 8? Well, I multiplied times 4. So if I multiply times 4 here, I get 28, which is what we just got, 28 students. So this is, like I said, when we were first doing that, find the missing number, when we were working with ratios, I said, y'all are doing algebra already. You've been doing it since probably 5th grade. I know I'm teaching this to my 6th graders as well. It's just now we're incorporating it into more of a equation form. So it's very simple. You understand the process. So don't get so caught up in, oh my gosh, this is brand new. It's really not. You've done this. Y'all have got this. I'm not worried. Okay. So let's move on to our second example. My test keeps disappearing. Okay, so okay, so example 5. Sam can paint 200 feet of privacy fence in 3 hours. This sounds familiar. To the nearest foot, how many feet can he paint in 5 hours? All right. So again, this one's like a rate of speed. How fast is he painting? And so think of how we drive. It's always miles per hour. So I'm going to write this as feet per hour. So our example 5, we have his rate of 200 feet in 3 hours. And I want to know how much he'll paint in 5 hours. Okay, so again, we have 3x equals 200 times 5. So 3x equals 1,000. That's 10. Okay. And when we divide by 3, we get one of those repeating decimals. So x equals 3 goes into 10 3 times with 1 left over. 3 goes into 10 3 times. 3 goes into 10. So 333 feet. It's going to keep going. So 333 and a third feet is our actual answer. You can round it. They rounded, I think, in the book to just 333 feet. But that tells us how many feet he could paint in 5 hours. All right. Now I did the alternate method. Did I? Hold on. They have the regular 200. Oh, okay. So I set it using the rate feet per hour. Yesterday in class, we learned that there's different ways that you can set a proportion. There's the inverted method, and then there's the alternate method. So I kind of did the inverted, feet per hour equals feet per hour. You also could say that 200 feet is to some unknown number of feet, but 3 hours is to 5 hours. Oops, HR. And if you do that, you see that you still get the exact same equation, right? This one's 3x equals x equals 200 times 5. This one, that's the same thing. You get 3x equals 200 times 5. So as long as they still end up being the same equation, you're going to end up with the exact same answer. So you end up with 333 and a third feet. All right, we have skill check 3. Write a proportion and solve. Sure. I've got a split screen. I'm not entirely sure how this is going to look on the video, so I apologize if it's like super small or weird or messy or whatever. But it certainly makes me a little bit faster. Okay, so for skill check 3, they have asked us to write a proportion and solve. So if 2 carrots, I'm not sure if y'all have your books or not, equals or costs 27 cents. How many carrots can you buy for $1.35? $1.35. Okay. So I'm gonna do like 2 carrots per 27 cents. So 2 carrots per 0.27 equals how many carrots for $1.35? All right, so I'm gonna cross multiply here. So I have 0.27x equals 2 times 1.35. I'm going to go ahead and combine those. 2 times 5 is 10, carry my 1, so that's a 7, and then 2. So that's $2.70. That helped. And then when we divide by 0.27, where they're really giving you some practice with your decimals. All right, so x equals, if I move that 2, I have to move that 2, so that's like 27 and 2. So looks like 10. 27 goes into 27 one time and 0, so 10 carrots. All right. Is that the answer? Yes, 10 carrots. The second one, oh boy, I love when they do these. By love, I mean I don't. And I know you guys, it drives you crazy. Okay, if 7 of 15 coins are dimes. Ooh. So 7 of 15 coins are dimes. Then 14 of how many coins will be dimes. So I'm gonna take a wild guess and guess that 7 is half of 14, then 15 is half of 30, that it's probably 30, but we'll get it set up here. Will be dimes. That's part of why they do this. So logically, you know the answer. You can sort of figure it out. But that just means that when you have to focus on the setting up the problem. It's the process that's more important than getting the answer right. You know the answer. What I need you to learn is how to set up the problem so that you could solve it if it were not so easy. All right, so we could do this one of two different ways. We could say that 7 is to 14, what 15 is to x, or, and then we would reduce. Yeah, I don't like that one at all. Or we could set up that 7 is to 15. Yeah, that one doesn't work at all. 15 to x. Actually, yeah, it would, but that would, that'd be some ugly math. 7 is to 15, what 14 is to x. All right, so see, we end up with the same thing. We have 7 times x and 15 times 14. And so we end up with 7x equals, then 15 times 14, 615, 0, 210. 7 goes into 21 3 times and 0 times, so coins, 30 coins. Yeah, so in this example, you using the whole concept of multiplying, like there's nothing you can multiply 7 times that gives you 15, and 14 times, some arbitrary number, certainly not a whole number, gives you 30. So you would do best to just reduce it. You'd have to reduce that to 1/2. And then you would say, oh, 1 is to 15, 1, 2 is to 30. All right. So that covers the rest of this lesson. We'll do a little bit of practice in class. I'm not going to give you guys any homework tonight. We're going to practice some of the word problems in class. So make sure you've watched this and kind of understand how to read and gather the information from them. And then we'll move on to the next section. All right, that's it. I'll see you guys tomorrow. Bye.